All right, in this video, let's create a new behavior type. We're more specifically going to be addressing the wander behavior. Now, just a quick overview of the behavior itself. The idea of wandering is going to be a behavior that will cause an actor to want to move in a specific direction that changes occasionally. So as the actor is wandering, every set interval is going to change its direction to a new direction. And given this new random direction, it will give the appearance of wandering. So to create the wandering behavior, we'll jump over to the behavior code over here in behavior.cs. We'll jump down to the very end of the file and create a new class for wandering behavior. So we'll create a class. This class is going to be called behavior wander. It will, of course, extend behavior. Then inside of the class, we're going to need to store a little bit of state information. First off, since we want behavior to act in a random sense, we're actually going to need a random object in order to generate the new directions that we're going to wander in. And we're also going to need to contain some timing. And what I mean by that is we need to remember exactly how often to recalculate a new random direction. So to put both of these in place, we can begin with the random object. We'll make a static random object called random and set that to a new instance of random. Now you notice what's actually happening here is regardless of how many instances of behavior wander we end up with, we'll only ever have a single random object. Really, we're just getting a random object that's in scope here inside of the behavior wander class. And since we don't need to worry about seeds, we're not going to be too specific about what's creating this random value. We'll make sure we set this to static, that we don't have an unnecessary number of random objects getting instantiated every single time we make new wandering behaviors. All right, now we need to put together some fields that will record some timing intervals. And the way we'll record these is in terms of game updates. We'll actually call those ticks here. So the idea is that each update counts as a single tick worth of time passing, and we have to accumulate a number of these ticks in order to fill up an interval. Every time we fill up an interval, then we'll recalculate a new direction. So for our fields, we'll make an integer called change interval, and a second integer called tick. The idea is that we'll use the tick integer to accumulate updates as they pass, and we'll use change interval as a value that we can check tick against to tell if it's time to change our direction. Now, I will note this in the timing system, since this means that we'll be setting our interval in terms of game updates. So that means if we were to set an interval of 60, and we're running our game at 60 frames a second or 60 updates a second, that means that an interval of 60 would equal 1 second. Now, depending on your specific scenario, you may want to set this in terms of seconds in general. So what you could do is instead of storing integer values, you could store double values in terms of seconds, then pass in a game time instance to your wandering class as you're updating it, or as you're constructing it. I guess it'd have to be both. Really, you'd want updates so that way you could see how much time has passed. But in doing so, you could calculate everything in terms of seconds instead of ticks. Just pointing that out, that we're using an integral tick counting system just for the sake of simplicity. Of course, any type of system that will count a threshold, fill that threshold, and reset could be used, including individual seconds. All right, one more thing we do need to store as far as our state for the specific instances of behavior wander is the direction that we're currently trying to move in. So we'll drop down a vector2 field called direction. All right, now when we're setting up a new instance of behavior wander, in addition to the behavior's weight, we also need to feed in the interval that we want to be applied to this behavior wander. So we'll make our public constructor, public behavior wander, and we'll set up our constructor to take in the first parameter as a float for our weight, and a second parameter to specify the change interval. So int change interval. Then we will make sure we chain this to our base constructor, passing in the weight value. Then we can drop in the braces for the constructor itself. And here we're simply going to record that change interval. So we'll do this dot change interval is set to the parameter change interval. All right, now that we have our field set up, now we can take a look at our update method. This will, of course, begin with an override to update. Then we will simply take out the call to base.update. Now, here inside of update, the first thing we need to do is manage timing. We need to look at our tick accumulation value and see if it's at a point that we're going to call the trip point, the point at which we recalculate our random direction. We're going to use the value 0 to indicate the point that we want to recalculate. So anytime tick is equal to 0, we will recalculate a new direction. That's going to be expressed here with an if statement. We can say if tick is equal to 0, then direction, really that could be this dot direction, is equal to actor dot get random direction. So that way we'll give ourselves a new random direction. Now, regardless of whether or not we recalculate, we do need to continuously count time, and we'll do that by incrementing tick. So we'll simply have tick plus plus. Now we want to make sure that this value wraps around to 0, otherwise we'll only hit this condition once and then never again, since tick will continue to go positive. So what we'll do is we'll take our tick value and we will calculate it as modulus against the change interval. Excuse me. So what we'll say is tick modulus equals change interval. To be more specific, we could say this dot change interval. So this is what allows us to reach the trip point repeatedly. Every time we advance tick, if we manage to advance tick to the full count of change interval, then that division will result in no remainder. So we store that remainder into tick, back into tick. Then on the next update, tick will again be equal to 0, and that will cause us to recalculate a new random direction. All right, now that we've taken care of the timing code, we may need to make sure that the current direction, as we're calculating update by update, gets applied to the actor. So we'll take our actor's direction, and we will add to that the direction we're currently looking here in the behavior, that is this dot direction, then multiply that against this dot weight. So that way you could almost see this is in two pieces. All this code is simply responsible for timing and direction recalculation. Then regardless of what happened in the timing code, just take the current direction and apply it as normal. We could actually compare this with the constant behavior, which does the exact same thing with direction. So you could say that our behavior wander is basically a behavior constant that occasionally points in a different direction at random. All right, with this new behavior class put together, we can now turn back to the game class and put it into action. So here inside of game 1, what we'll do is we'll look at our leader actor, we'll look into its behavior list and add a new behavior. More specifically, we'll add a new behavior wander instance. Now for the weight of our behavior wander, we'll specify a very low weight, a value of 0.05 floating, and a change interval of 60. So again, if we're running 60 updates a second, that will be a change once every second. Now we can close off the call to behavior wander, one more close off the call to add, and that takes care of the new behavior wander. Now at this point, we have gamepad input layered in, we now have wander input layered in, and so we do not need our behavior constant any longer. The behavior wander, actually, here I go pressing random buttons again. That jump back to behavior was simply hitting a stray button on the keyboard. Back in our game class under load content, what I'm going to do now is take out our behavior constant. So we'll instead just blend between random wandering and gamepad behavior. So with this in place, let's build and test the result. So jumping into our game here, watching the actor without even touching the controller at all, you can see that the actor now, well, wanders. Every so often he decides that he doesn't like the direction he's going and goes and wanders off in a new direction. And then the interesting thing is, since the behavior is, again, applied over time, the moment the actor decides on moving in a new direction, he actually has to curve to meet that new direction. So he instantly calculates a new direction he wants to be moving in. It just takes time to actually reach that direction. Plus, with the behavior system being layered, it means I can at any moment begin influencing the actor by moving the gamepad. So even though he's trying to wander, I can take the gamepad input, which is layered at a much higher value. So we have 0.05 for the wandering and 0.5 for the controller input. So the wandering behavior is almost imperceptible as long as I've got the controller. You can just see a very faint amount of moving up and down as I'm controlling with the controller. And of course, if I let go of the controller, then the only thing influencing the input is the wandering, so the wandering is very pronounced. But with that, we now have wandering behavior fully in effect, and as with all behaviors, able to be layered in with all of the current behaviors for our actor. So with that, that's going to wrap up this video.